remember, we're going to keep our framework within just 2 goods. It gets very complicated if you try to add more than 2 goods. So under our optimal allocation rule, we must satisfy 2 conditions. And those 2 conditions are, we must spend all of our income, and the second condition is that the margin utility per dollar needs to be equalized across both goods. And I'll talk about that more in a moment. So let's talk about rule number 1, which I've repurposed with the information we're going to use here in just a moment. So in the example we're going to talk about in a second, we're going to be talking about finding an optimal allocation of slices of cherry pie and glasses of milk. And again, what we're looking for is that utility maximizing combination of the 2 goods. When we say the word allocation, what we mean is what combination of the 2 goods makes us the happiest. And again, this can be a relatively difficult question to ask, although seemingly simple. So if we look at income, and again we just have our general budget constraint here, rule number 1 says we must spend all of our income. All this simply means is that the number of slices of pie we eat times the price of pie plus the number of glasses of milk we drink times the price of milk must equal M, where M is our income. So again, we just need to spend all of our income. If we ever spend less than our income, then we're not maximizing utility, and we are unable to spend more than our income. All right, rule number 2, margin utility per dollar equalized across both goods. Margin utility per dollar is simply the margin utility at any given amount divided by the price of that particular good. So the margin utility per dollar of pie is the margin utility of pie at a given amount divided by the price of pie. The margin utility per dollar for milk is the margin utility for milk at a given quantity divided by the price of milk. And again, we need these to equal each other. If these do not equal each other, then this is not an optimal allocation. And again, you start to understand, or hopefully start to understand, how thinking on the margin will allow us to get to this notion of an optimal allocation. And just one more reminder, the optimal allocation must satisfy both conditions. If either condition is unsatisfied, we are not choosing an optimal allocation. Okay, so in the upper left-hand corner here we have our cherry pie information, the data on utility from cherry pie, and then over here in the right-hand corner we have new data. This is data on glasses of milk. And just take a second here to look at what happens with milk. Again, the same situation, we have law of diminishing returns. So as we consume greater amounts of milk, notice that our margin utility rises at first and then falls very quickly. In fact, notice that if we drink too much milk, we will in fact be unhappy. We will receive negative utility. Okay, so we're going to assume that we have $7 worth of income to spend, that the price of pie is $2 a slice, and that the price of milk is $1 a glass. And again, we're going to need to satisfy both of our conditions in order to find an optimal allocation. Now, unfortunately, we are unable to use calculus-based techniques for utility maximization, which is, in reality, actually the simplest way to do it. And so in order for us to keep it within the confines of a principles class, we have to, unfortunately, kind of use a process of elimination or a sort of process of error. In other words, we're going to pick certain amounts of the 2 goods, and then we're going to check them to see if they are indeed optimal, checking to see if they meet both conditions. So what about 3 slices of pie and 2 glasses of milk? That sounds like a pretty good allocation to me. And so we're going to want to check to see if this could potentially be an optimal allocation. So if we, hold on one second, if we bring up the notion of 3 slices and 2 glasses, what we quickly realize is, in fact, we cannot afford 3 slices of pie and 2 glasses of milk. Each slice of pie, it costs us $2, so 3 slices of pie would mean we spent $6 on pie, and each glass of milk is $1. So if we bought 2 of those, that would be $2 on milk. And we add that up, and we find out that immediately this cannot be an optimal allocation because we can't afford it. As I mentioned in class, a lot of times students will make the mistake of assuming that utility maximization is only ever one thing. In other words, you have a favorite food, or you have a favorite place to visit, or you have a favorite clothing company, and if you're not consuming those goods, how could you possibly be maximizing your utility? But optimal allocations rely upon two things: utility, and also we have to be able to afford it. Because if you can't buy anything, then it's really pointless to discuss the notion of happiness. How could it make you happy if you couldn't afford it? So, very quickly, at 3 slices of pie and 2 glasses of milk, we find out we can't afford it. So we can get rid of that. All right. So clearly, in that example, we're consuming too much. So what we might believe is that instead of 3 slices of pie and 2 glasses of milk, let's buy less pie, but then buy 1 more glass of milk. So 2 slices of pie and 3 glasses of milk. So if we look at that, again, what we notice very quickly is that we actually can't afford this bundle. So at $2 a slice and buying 2, that's $4, plus $1 a glass of milk times 3 is $3, and that adds up to $7. So we can afford it, and it is spending all of our income. But then we have a problem. So when we go to maximize marginal utility per dollar for the 2 goods, and again, remember that we're measuring marginal utility per dollar at a particular level of consumption. So 2 slices, so what we need to do is we go up to the marginal utility at 2 slices, and we can see that the marginal utility at 2 slices is 15. So we take 15, we divide it by 2, the price of pie, and we get a marginal utility per dollar of 7.5. Then, if we look at the marginal utility of 3 glasses of milk, we will see that it's 1. And then we divide that by the price of milk, $1, and we get a marginal utility per dollar of 1. And as most people would know, 7.5 does not equal 1. Now there's another important point here. Not only do we know that this is not an optimal allocation because it doesn't satisfy both conditions, we also know which good we need to consume more of. And so, as a general rule, we can look at the marginal utility per dollar between the 2 goods, and whichever one is higher, this is what we should be consuming more of. And whichever one is lower, that's what we should be consuming less of. Now this should make a lot of sense. If I were to tell you, okay, you can eat a slice of pie and it will make you happy by a certain amount, or you can drink a glass of milk and it will make you happy by a lesser amount than the pie, why would you drink the glass of milk instead of eating the slice of pie, assuming you could afford it? And the answer is you wouldn't. So in order to maximize utility, you're going to want to consume whichever one has the highest marginal utility per dollar. In other words, you're going to consume the one that's giving you more utility for your money. And so in this situation, this informs us that we should be consuming more pie and less milk. So, if we should be consuming more pie, less milk, what about 3 slices of pie and 2 glasses of milk? Well, unfortunately, as we found out just a moment ago, we cannot afford 3 slices and 2 glasses of milk. Right? We cannot afford that, so this cannot be an optimal allocation. So, what about 3 slices of pie and 1 glass of milk? So let's check that out. So if we bring this up, shrink these down, get those out of the way. So if we look at this, so what about 3 slices of pie and 1 glass of milk? Again, we first check our budget constraint. 3 slices of pie at $2 a piece is $6 on pie. 1 glass of milk at $1 a piece is $1 on milk. And there we have it. We meet our budget constraint requirement. So then we can move on to the marginal utility per dollar requirement. And in fact, if we look at the marginal utility per dollar requirement, again, at 3 slices, the marginal utility of pie is 10, divided by the price of pie, $2, and we get marginal utility per dollar of 5. At 1 glass of milk, we see that marginal utility is 5, divided by the price of milk, $1, and bingo, we have an optimal allocation. And this is optimal because, again, we spend all of our money and our marginal utility per dollar is equalized across both goods. Now, this may seem confusing at first. How does this in any way, sort of actually show us the utility maximizing allocation of the two goods? And again, this goes back to thinking on the margin. Basically, what happens is that when margin utility per dollar between the two goods equal each other, this means is I can't make myself happier by consuming more of either good, right? So in other words, if I were to consume more pie, right, than 3 slices, then margin utility per dollar for pie would be lower than the margin utility per dollar for a glass of milk. Therefore, I should be consuming less pie. If, on the other hand, I decided to, instead of 1 glass of milk, I decided to drink an additional one, I would find a similar situation. I would be consuming too much milk. It is at 3 slices of pie and 1 glass of milk that I am maximizing my utility. Thus, we can say that 3 slices of pie and 1 glass of milk is an optimal allocation under this condition.